All right, everybody, welcome to section 5.2, which relates what we already know about transformations to our sine and cosine graph. So what I've already done is I've already taken the graph of y equals cosine theta and I've drawn it on the board. And what we're going to do is we're going to relate it to the graph of y equals cosine x plus 45 degrees, subtract 2. And so I've already done a mapping of that as well. And you can see it's taking the green and going, or from the red, pardon me, and going to the green. And once we get that down, we will be in good shape. Sorry, I just had to fix my toolbar there. All right, still there. So we're going to go from the red to the green. So the red is already drawn. We're now going to draw the green. I'm going to show you two different ways to do these types of questions, and you can pick the one that you like. This is the one most of you have been doing, and you're basically taking test points or points that are already there, and you're mapping them to a new point. An image point of that point. So let's start with the red point right here, which is 0 and 1. And we are going to add 45 degrees to the x value. Now, in terms of radians, that would be pi over 4, or the middle between 0 and 90. So we're looking at a value. You can see me marking on the number line there, where your x value would be, and your y value is going to go down 2. Now, your y value is at 1, and we're going to have to go down 2. So this would be 1, 2. That would be the point right there. So we now have a new point. The next image point we have is at pi over 2 and 0. We're going to need to extend the page right here. All right, at pi over 2 and 0, we add 45 degrees to pi over 2, which is taking us to right there. And we subtract 2 from 0, and we're at minus 2, so minus 1, minus 2, and now we're at the point right there. And you can probably predict how this is going to behave, but let's go ahead and do one more anyways. We are at pi and minus 1 for the next point that we're going to image point, and so we're going to add 45 degrees to that, so that would take us between pi and 3 pi over 2, and we're going to go down 2. So from here, we're going to go down to 1, 2. That takes us down to there. And just using even reflection and symmetry, I know my next point is going to end up here, and then taking that point and moving it over to here. We can see the shape of the graph is going to be there, where our 0 line, or our equilibrium line, or our x-axis has basically been moved down 2. There's been no horizontal or vertical stretch, so the graph looks pretty much the same. That's the image point method. The other method that you can use is one that I used to use more often, and that is relating the original period length of sine or cosine to a new period length. But before we talk about that, let's just make sure that we understand that the new graph is going to be up 2. So before I even deal with the starting and end point, we're going to first say, well, we know that's going to be up 2. And we also know there's going to be a vertical stretch by a factor of 2 as well. But the first thing that I'm going to look at is, where is this graph going to start and where is this going to end? So for regular sine, the angle is always, not the angle, the period length is between 0 and 2 pi. That's one of the period lengths that you could draw of sine. And so what we're going to say now is, well, how is theta being changed here? Well, theta is no longer just theta. It's theta subtract pi over 2. So to get theta by itself again, I'm going to add pi over 2 to each side. Now, 2 pi as a fraction of pi over 2 is 4, so we'll end up with 5 pi over 2. All this is saying is that your original sine function has been shifted pi over 2 to the right. So I'm going to mark these values on my number line. Pi over 2 is going to be here. And then I know that whenever we draw this, you're always going to use, for one period length, one period length anyways, you're always going to use 5 markings. So I'm just going to extend this line a little bit. And I know that I'm going to use 5 markings to draw one period length. 1, 2, 3, 4, 5. So here's 5 pi over 2. Now to find the middle between any 2 points, you just average them. So we're going to add those together and divide by 2. So what you end up with is 6 pi over 2 when you add them together, which is 3 pi. Divide that by 2 is 3 pi over 2. And then to find the middle between any other 2 points, you add them together and divide by 2. So 3 pi plus pi is 4 pi over 2, which is actually 2 pi divided by 2. That's going to be pi. And the middle between here and here is going to be 2 pi. So that tells us where we're going to start and where we're going to end drawing this new sine function. So what happens now is I'm just going to take these values and I'm going to plug it into this equation and I'm going to get my points. So I'm going to start with y equals 2 sine of my first theta is pi over 2. So I'm going to put in pi over 2 and then add 2 to that. So if I just start in the middle there, pi over 2 minus pi over 2 is 0. The sine of 0 is 0. 0 times 2 is 0. And 0 plus 2 is 2. So my graph's going to be at pi over 2 and 2. So I'm going to make each one of these blocks worth 1. So that's at 2. Then I'm going to put pi in. If I put pi in for theta, pi take away pi over 2 is pi over 2. The sine of 90 is 1, or sine of pi over 2 is 1. 1 times 2 is 2. 2 plus 2 is 4. So here, I'm going to end up at 4. And I can continue on, and all you're going to feel like is you're just going around the unit circle here, because now when I put 3 pi over 2 in, 3 pi over 2 minus pi over 2 is 2 pi over 2, or pi. The sine of pi is 0. 0 times 2 is 0. You're back at 2. And then you can predict what's going to happen next. When you put 2 pi in, you're going to get 3 pi over 2, which is minus 1. Or, yeah, you're going to end up with a value of 0 here. And then you're going to go back up there. And you can see the shape ends up like so. So it has been vertically stretched without us even considering a mapping diagram like we would in the previous example. Both methods are equally valid. Personally, I like the one that I'm more comfortable with, which is this one, but whatever one you end up being comfortable with is good for you. The thing with the mapping diagram is sometimes you end up estimating points more, and if you end up using this kind of interval method, you'll end up doing less estimating and more exact. But you don't get the sense of the stretching and the shifting as much. So there's positives to both. That's it. We'll do a couple examples in class tomorrow and then work together.